We will see how to work out assignment problem, data given is balanced and which has multiple solutions. So we will take this question number 4. A toy company has 4 men available for work on 4 separate jobs. So there are 4 persons and there are 4 jobs. That means each one should be assigned one particular job. And that means number of persons and number of jobs, number of rows, number of columns are equal. So the data is balanced. The objective is to assign men to jobs in such a way that the total cost of assignment is minimum. So what is the first thing that you have to identify? We have to see whether it is a minimization problem or a maximization problem. What is the objective? So the objective here is, what is the objective? The objective is minimization. What is objective? Objective is minimization. And that means the cost data is given to you. We have to minimize the total cost. Do you understand? There are 4 jobs, 4 persons. Each job should be assigned to each person in such a way that the total cost of completing all the 4 jobs is the least. Okay, so that's the question. Cost matrix is given to you. So we will start working out the sum. First one, as I told you, identify the objective. What is the objective? The objective is minimization. Second one, identify the nature of data. What is the nature of data? The nature of data is balance. Why do you say it is balanced? Number of rows is equal to the number of columns. There are 4 rows and there are 4 columns. There are 4 persons, there are 4 jobs. So the data is balanced. And after you finish the step 1 and the step 2, now we have to do the row operation. How do you do the row operation? For each row, you see what is the least value. So there are 20, 25, 22, 28. What is the least? Least is 20. So this is the row minimum. Now, second one, 15, 18, 23, 17. What is the row least in this particular row? It is 15. So row minimum is 15. Here, the third row, 19, 17, 21, 24, which is the least? Least is 17. 25, 23, 24, 24, least is 23. So identify what is the row minimum. And after you find out the row minimum, for the first row, you know, row minimum is 20. Therefore, it is whatever value you have in this particular cell minus 20. Similarly, it is 25 minus 20, 22 minus 20, 28 minus 20. So what did we do? This is the first row. 20 minus 20 minus 20 minus 20 minus 20, because row minimum is 20. Now the second one, how do you do? It will be 15 minus 15, 18 minus 15, 23 minus 15, 17 minus 15, and so on. So how do you find this? It is 15 minus 15. And you can complete this particular row in the same manner. Third one will be 19 minus row minimum is 17. So complete this particular row. Fourth one is 25 minus 23, 2, and complete this. So we have done the row operation. This is the third step. Row operation is completed. Now what should you do? You find out what is the row minimum. So what is row minimum means? Not row minimum, column minimum, because row operation is already over. We are moving on to step 4, column minimum or column operation. So in this particular column, what is the least cell? Least value. Least value is 0. In this particular column, what is the least value? It is 0. In this particular column, what is the least value cell? It's 1. In this particular column, what is the least value? It is 1. So we found out what is the column minimum. And now for the first column, it is 0 minus the column minimum. So how you did for the row minimum, same way, 0 minus the column minimum is 0, 0 minus 0, 2 minus 0, 2 minus 0. You will get the same thing because it is 0, you will get the same values. Right? Now here also it will be 5 minus 0, 3 minus 0, and so on. So you will get same values. And then here it will be 2 minus 1. Why 2 minus 1? Because the column minimum is 1. So 2 minus 1, 8 minus 1, 4 minus 1, 1 minus 1. This is column minimum, column operation. Next one, it is 8 minus 1. So we have done the column operation. How we did the row operation? In the same manner, column operation is also done. After you do the row operation and the column operation, then you have to see whether the matrix is feasible for optimal assignment. So next one is the optimality test. So optimality test, what do? Copy this particular matrix, whatever matrix that you have obtained, copy that particular matrix. I've copied. Now, what should I do? You see the row or a column which has maximum number of zeros. See here, there's only 1 0, 1 0, 1 0, 3 zeros. Here, 2, in this particular column, 2, 2, 1, and 1. I think 3 is maximum. So please draw a line which covers 3 zeros. And then I think if I draw this way, that two, it covers 2 zeros. If I draw this way, it covers 2 zeros. So now what we are going to check, whether this matrix is feasible for optimal assignment. The answer is no, it is not feasible for optimal assignment. Reason being, the number of lines drawn is not equal to the order of the matrix. You have drawn 3 lines, but the order of the matrix is 4, 4 cross 4. So number of lines drawn is not equal to the order of the matrix. So now what we have to do? We have to modify this particular matrix. This particular matrix needs to be modified. Now, what is the rule for modification? This is whatever values that you have, which is not covered by the lines. See, for example, 1 7 7 1 3 6. There's no line going across these numbers. So these elements are called open elements. They are called open elements, and the numbers which are crossed, which are covered by the lines are closed. Do you understand? So these are open and these are closed. So you have to find out from the open elements which is the least value. What is the least value? Least value is 1, because 1 7 7 1 3 6. So you write here least open element. So least open element is 1. And how do you modify this particular matrix? The rule is add LOE. LOE means least open element. You have to add it to the junction points. Now, what do you mean by junction? Where you find that there's one line like this and one line like this, where the two lines intersect. So this is known as the junction point. To the junction point, you have to add the LOE. That means here you have, this is junction, 2 is junction, so you have to add 1 to this. The 0 is a junction point, add 1 to this. Whereas these are not junction because there's only one line going, not 2 lines. So at the junction point, you have to add the LOE. That is the least open element you need to add to the junction. And for the open elements, you have to minus the LOE. So it will be 1 minus 0, 7 minus, 1 minus 1, 7 minus 1, 3 minus 1, 7 minus 1, 1 minus 1, 6 minus 1. So for the open elements, you have to subtract 1. That is the least open element. Whatever the least open element, you have to subtract. For the junction point, you have to add. But we're covered by only one line, which is not a junction point. You have to leave it as it is. So what should we do now? It is, I'll take this again, the same thing. This I will copy it and I'm going to modify it here. So how am I going to modify it? This is covered by one line. I'll just color it so that there's no confusion. This is also covered by one line, and this is covered by one line. Okay, so these are the intersection junction. This as well as this. These two are junctions. So you have to add LOE. So 2 will become 3 and 0 will become 1 because you're adding 2 plus 1 and 0 plus 1. Whereas the open elements, what should you do? It is whatever the element that you have minus 1. So you know it is 1 minus 1, 7 minus 1, 7 minus 1, 1 minus 1, 3 minus 1, 6 minus 1. So 0, 6, 6, 0, 2, 5. So I have modified this. I modified the matrix. So what did I do? Same thing. You know that wherever you have junction, you need to add 1. Junction points, add 1. Open elements, you need to subtract 1. So when you do that, you get the revised matrix. So this is the revised matrix. Again, you need to check for optimality. So how do you check for optimality? See a particular row or a column which has maximum number of zeros. So here there are 2, here also 2, here 1, and here 2. Here 2, 2, 1, 2. So 2 is maximum. So I'll cancel this. I'll cancel this. I can draw like this. It covers 2 zeros and the last one like this. So 1, 2, 3, 4. So number of lines drawn is equal to the order of the matrix. So number of lines drawn is equal to the order of the matrix. That means it is feasible for optimal assignment. Number of line drawn is equal to the order of the matrix. That means you can um, make the assignment now. It is feasible for assignment. So I'm going to make the assignment. So how do I make the assignment? Copy these values. Copy the matrix. I'm going to make the assignment. So you find out a particular row or a column which has only 1 0 in it. That is how you do the optimal assignment. Here in the first row, there are 2 zeros. Second row, 2 zeros. Third, only 1 0. So make the assignment. So in this particular column, if you have zeros, you have to strike it off. So it is not possible that there are no zeros to strike it out. Now, again, when I see there are 2 zeros, 2 zeros, and 2 zeros, column wise, 2 zeros, 2 zeros, 2 zeros. So column wise also 2, row wise is also 2. So that means this will have multiple solution. Therefore, because it has multiple solution, because you don't have 1 0 to assign. Okay. So now what I will do, I will copy and I'll write it here because I know I have multiple solution. So I'll copy it here. I'll say or this is already assigned. Okay, I've just copied this here also because I'm going to make some assumption. Now, what is the assumption? Because everywhere, every row and every column has 2 zeros. So I'm saying if the first job, because this is 0, if the first job is assigned to A, then what happens in this particular row? You can cancel out this. In this particular column, if you have 0, you have to cancel it out. Now, you could say instead of assigning A with job 1, it is possible that you can give job 3 also. Therefore, this will be cancelled and this will be cancelled. In this particular row, if there are any zeros, you cancel. In this particular column, if there are zeros, you cancel. Okay. Now coming to the second one, come to the second row. Second row, now there's only 1 0 assign, cancel out this. Third is already assigned and this is the fourth one. So this is the optimal assignment. Now, in this case, what happens? The second row, 2 zeros. Third row, it's already assigned. The fourth row, only 1 0. So I will assign this. This I will strike it out. So this will go to this. So this is the optimal assignment, and you have multiple solution in the given problem. So job 1 is assigned to A. So you have to see what is the time it will take. So go to the cost matrix. So what is the cost? It is 20. So this is 20. Job 4 is given to B. So B is assigned with job 4. So what is the cost? 17. C is assigned with job 2. So C is assigned with job 2, 17. And D is assigned with job 3, 24. Job 3, 24, it is 78 rupees. Now, this is the, I said alternate solution. So here also you can check what happens. So A is assigned with job 3. So job 3, if you assign, then what will be the cost? A assigned with job 3, 22. Job B is assigned with job 1. Job 1, if you assign 15. Job C, job 2 is assigned to C. C job 2. C 2 is 17. And E is assigned with job 4, 24. So see the time, see the cost. The cost is 78 rupees in both the cases. So this is also optimal solution. This is also optimal solution. So this for this particular problem, you have two solutions. Therefore, we found out both the solutions. I hope you have understood. Thank you very much. Have a great day.